Okay, number 31. Which of the following is a longitudinal wave? If you recall your electromagnetic spectrum, all except sound are components on those. So infrared, X-rays, and radio waves, those are all transverse waves. They're all spectrum of electromagnetic radiation, light. So the answer is C, sound. Number 32. The diagram shows a cross-section of water waves. Okay, we just mentioned transverse waves. Water waves are also transverse waves. Okay, so we're looking for the wavelength. The wavelength is the distance traveled over one cycle. Let's mark off what a cycle looks like. Okay, so we can mark off a cycle. If we start here, we're going to go up a crest and come back down to the trough. Okay, so that would be a cycle, any two successive points. This is also a cycle from crest to crest. Let me do that in a different color. Okay, so from crest to crest, or if we start from the equilibrium position, okay, kind of go from here, go down, come up, come back here. Okay, so all of those are one cycle. So if we look at what we're given the distance from this point to this point as 20 meters. But there's another crest in between here. So this is 1, 2, 3 successive points. A wavelength is the distance between the two successive, and by successive I mean one after the next. So the wavelength would be half of this 20, which would take us from here to here. So that would be 10 centimeters. C. Number 33. This diagram shows isolated charged and uncharged spheres placed near to one another. In which example will the spheres repel one another? Okay, so in order to get repulsion, we're looking for like charges. So which two are alike? So this is no charge and positive. So no. We have positive and negative. Well, that's going to be an attraction because they are unlike. Same situation here. We're just going to get no effect with this no charge and negative. So our answer is D. Two positives, they will repel each other. Same thing would happen if we had two negatives. They would also repel. Okay, number 34. A metal case toaster is to be connected to the mains, which diagram shows the correct wiring and placing for the switch and fuse. Okay, so this is our ring circuit diagram. Circuit, right, that's spelled bad. Ring circuit. Okay, what you need to remember about this is that on the ring circuit, only the live wire has fuses and switches. And it makes sense because that's the one that's carrying the current. Okay, the neutral wire's purpose is to take the current back to the power station. And so we have three types of wires. We have live, neutral, and ground. Okay, so we're looking for a diagram that has fuses and switches on the live wire only. So here, that one's out because we have a fuse on the neutral wire. We look at the others, similar situations, okay. Live, neutral, and earth, okay. Ground is also called earth. So that's what the E stands for, ground or earth. Okay. And I know B and C look very similar as well, but you want to look at this section right here. What makes them different? This little dot is telling you that this wire is connected to the body of the toaster. Now, that is in case we have a fault. We want all the current to go to ground, to go to earth. Remember, the ground wire is there as a precaution to send all the current into the ground and away from the toaster so that when you touch it, you don't get shocked. So this one is no good, because if we have a fault, then the current will just be circulating and building up right here on the toaster. It's not going to have a place to escape. So we'll still get unfavorable outcomes. So our answer is this one here. So there are two things that we needed to look for. You need to look that the live wire has the fuses and switches only, and that the earth wire is connected to the body of the toaster. Okay, number 35. The circuits show two identical lamps connected in various ways to either one or two 2-volt cells. In which circuit will the voltage across a single lamp be 1 volt? All right, so it might be helpful to fill in what the voltage is in each case. So we have one cell here, and it has a value of 2 volts. So the voltage in this circuit is 2 volts. In this one, we have two cells, two 2-volt cells. So we have a total of 4 volts. Here we have 2 volts, and here 2 volts. Okay. So what happens to the voltage in circuit A? Well, this is a series circuit, and so the voltage is split between the two lamps. So each of them will get 1 volt. Okay. And they're identical, which means they have the same resistance. So they're going to pull the exact same amount of voltage from the main supply. So let's check the other ones. This one, there's only one. This is in series as well. And there's only one lamp in this circuit. So it will get the total voltage, 2 volts. So C is not our answer. Here, we have a total of 4 volts to be shared among 2 lamps that are identical. So they will each get the same voltage drop across, so 2 volts and 2 volts. So B is not our answer. And finally, we have a parallel circuit. And in a parallel circuit, both of these lamps will get the same voltage equal to the source voltage. So they will each get 2 volts. So D is not our answer. So we got it right the first time, but it's very important that you are able to troubleshoot why the answer is correct. All right, that is it for this video. See you in the next one.